Okay, so today we're going to be talking about quantum numbers. Now, electrons in an atom are moving in a constant wave-like motion around the nucleus, so it is nearly impossible to pinpoint the exact position of any electron in an atom at a given time. Now, this contradicts Bohr's theory of a position of the electron, but in turn, the orbitals are an idea of where the electron might be. So that is why quantum theory is important, because it helps mathematically describe the properties of the wave-like motion electrons take in an atom. Now, each atom has their own quantum number code to describe the properties of their electrons that are developed through quantum theory. Now, these quantum numbers specifies the properties of the atomic orbitals, so the orbitals in the atom, and the properties of the electrons in those orbitals. And there are four quantum numbers, so let's go ahead and talk about them. So the first quantum number is called principal quantum number, and that is labeled as a italicized N. Now, the principal quantum number indicates the main energy level occupied by the electrons, meaning that, and also the values for this quantum number are positive integers. You're never going to have any negative ones, that are always going to be positive. So what I mean by energy level is that the quantum number, the principal quantum number, equals the number of orbitals, which we know to get the number of orbitals is the period or row number. Now, each orbital has their own main energy level. So the more orbitals there are, the more energy levels there are. So each electron will only occupy a certain energy level, will only occupy a certain orbital. So let's go ahead and do some of the examples of figuring out what the principal quantum numbers of specific elements are. So here's a periodic table. And let's go ahead and look at hydrogen. Now, we know that hydrogen is in row 1, so our principal quantum number is 1. Now, nitrogen. Now, nitrogen is in row 2, so our principal quantum number is 2. Magnesium. Magnesium is in row 3, so magnesium's principal quantum number is 3. And then we have copper. Now, copper is in row 4, so because it's in row 4, the principal quantum number is 4. That's all you'll do to figure out the principal quantum numbers. Now, our next quantum number is angular momentum quantum number, which is labeled as an italicized L. Now, angular momentum quantum numbers indicates the shape of the orbital. Now, there's 4 different orbitals, types of orbitals that we're going to talk about. And the first one is like it's a sphere. And this is an s orbital. Okay, so make sure you know that. Then we got a dumbbell. And this dumbbell is your p orbital. And now putting two dumbbells together, you get this shape, which is kind of like a 4-leaf clover, and that is a d orbital. Then putting two 4-leaf clovers together, you get this. It's kind of like in a cubic shape, but you still have the two 4-leaf clovers, and that is an f orbital. So knowing these types of orbitals, the periodic table is broken up to 4 blocks that represent an s orbital, p orbital, d orbital, and f orbital. So looking at a periodic table again, we have this section of the periodic table. Now, helium is supposed to go next to hydrogen, but because helium has similar characteristics as this group of elements, it's moved. So we're going to include helium with this rest of this first part of the periodic table. Now, this purple highlighted part of the periodic table is the s block. So any element in there that's in the s block has an s orbital for their electrons. Then, so because it's an s orbital, our L is going to equal 0. So if your element that you're trying to find the quantum numbers for are in the s block, it's an s orbital, so it's the L, the angular momentum quantum number is 0. Now I have this part of the periodic table, the blue part. Now the blue part of this periodic table is the p block. So p block represents your p orbital. So if there's an element in that block, your angular momentum quantum number, your L, equals 1. Then we got this part as well as this here. This actually inserts here. So because this is an insert to here to expand the periodic table more. And we'll talk a little bit more about that in a minute. So all this red part, we like to call that as our D block. Now our D block represents d orbitals, so any of the elements in the d block has an angular momentum quantum number, L equal 2. Then we have this bottom one here, this kind of insert into the periodic table, the yellow, and that is our F block, which represents our F orbital. So that means our angular momentum quantum number is 3. So remember, S block, S orbital 0, P orbital, P block is 1, D orbital, which is your D block, is 2, and F orbital, which is your F block, is 3. So let's go ahead and do some examples of that. So looking at chlorine, for instance. Now, chlorine is in our third row, so we know that our principal quantum number, N, is 3. So looking at where chlorine is compared to the block, we know it's in the P block. Since it's in the P block, it's a P orbital, and we know that when P orbitals have an L of 1, so chlorine's L equals 1. All right, so now let's go ahead and look at potassium. Now, potassium is in row 4. Since potassium is in row 4, we know that the principal quantum number is 4. Now let's figure out what that L quantum number, that angular momentum quantum number. Well, potassium, it looks like potassium is in the S block. So since potassium is in the S block, L equals 0, since anything in the S block has to have L equals 0. Now let's go and look at silver, Ag. We know that silver's in the 5th row, the 5th period, so N equals 5. Now, silver's in the D block. Since silver's in the D block, we know anything in the D block that has a D orbital, L equals 2. So Ag's L equals 2. Now, uranium. Uranium is it's kind of like you can't really figure out where the row is. Well, it says 57 to 71. That means all elements from 57 to 71 goes in this inner here. So after barium, it goes down here and then it moves back up. Same thing to go over here. So after radium, it goes down here and it goes up again. Okay. So let me just wait for the bar to move. So that means uranium is in the 7th period, the 7th row. Since uranium is in the 7th period, we know that N equals 7. Now uranium is also in the F block. Since uranium is in the F block, L equals 3. So our third quantum number is magnetic quantum number, which is symbolized as an italicized M. Now, the magnetic quantum number indicates the orientation of an orbital around the nucleus, and that value can either go from negative L to positive L, so negative angular momentum quantum number to positive angular momentum quantum number. So let's see what I mean by this. Again, looking at a periodic table. Now, we have our S block highlighted, and we know that our L equals 0 if it's in the S orbital, the S block. So that means, can we really have a positive or negative 0? No. So all the M's are going to be 0. That means all of those elements are going to have an M value of 0. So let's go ahead and move on to that P block. Well, P block represents our P orbital, and we knew that L equals 1. So that means our value from M can either go from negative 1 to positive 1. And this is how you will figure that out. You start from your beginning of your block. You go negative 1, 0, positive 1. Negative 1, 0, 0, positive 1. Negative 1, 0, positive 1. Negative 1, 0, positive 1, and continue on. Now it's kind of like the number line, right? The number line, negatives go first, then the 0, then the positive values. So it's kind of like what you're going to do from that beginning of that block set. Okay, so Moving on to our D block highlighted. Well, we know our D block represents our d orbitals, and that means that L value equals 2, so that means M can have a value of -2 to +2. So it'll kind of look like this. Very similar to our P block, but we have 2 involved, so we go -2, -1, 0, +1, +2, -2, -1, 0, +2, +1, +2, and so on and so forth, okay? And don't forget these two that are D block that kind of goes right here, okay? Then last we got our F block, which is on the very bottom. An F block represents our F orbital. We know L equals 3, so our M values go from -3 to +3. So those M values look like this. So we got our -3, -2, -1, 0, +1, +2, +3. Then we restart to -3, -2, -1, 0, +1, +2, +3, and so on and so forth. Okay, so let's put these ideas of to your M quantum numbers into examples. Now, going back to chlorine, now we know chlorine has N value of 3 and an L value of 1. So looking at where chlorine is on the periodic table, it says that our M is going to be 0, so our M 0. Then potassium, we know potassium has an N of 4 and an L of 0. Well, potassium looks like it's in the S block. We know M's are zeros, so our M is 0. Silver, we know, has an N of 5 and an L of 2. Well, looks like it's a +1 because we go -2, -1, 0, +1, +2, -2, -1, 0, +1. So our M value is +1. Then moving on to uranium, well, we know that and then just reviewing where these inserts go, we know that uranium has an N of 7 and a L of 3, so looking at your M values, it looks like in the place of 0, because we go from that -3, -2, -1, and 0. Sorry, this thing's covering it. So, let's wait for that. So our M is 0. So our last quantum number is the spin quantum number, which is labeled as M subscript S. Now that indicates the 2 fundamental spin states of an electron in an orbital. And that value can either be -1/2 or +1/2. Now figuring out if it's going to be a plus or a -1/2, again, we look back to our periodic table. Now our S block, it's going to go +1/2, -1/2, +1/2, -1/2, +1/2, minus, plus, minus, plus, minus, plus, minus, plus, minus, okay? Look at your P block, again, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, so on and so forth. Same thing with your D block, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. And your F block is the same thing, plus, minus, plus, minus, plus, minus, plus, minus, so on and so forth, okay? So again, doing examples of those. Again, we have chlorine. We already know chlorine is an N of 3, L of 1, M of 0. Looking at that MS, it's a plus, minus, plus, minus, plus. See, plus, minus, plus, minus, plus. So our MS is +1/2. Potassium we know was N4, L0, M0. Looking at it, starts as a plus, so it should be a +1/2, right? Plus, minus, plus, minus. So our MS is +1/2. Silver, we know N is 5, L is 2, M is +1. And it's in the place of +1/2. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So our MS is +1/2. Then uranium, we know uranium is N equals 7, L equals 3, and M equals 0. Since it's a plus, minus, we're thinking it's a -1/2. So it is. So MS is 1/2. So you're going to do some examples on your own. For each of these, you're going to determine the 4 quantum numbers, N, L, M, and MS, of the following elements. So go ahead and try that for lithium. And here's your answer. We got N equals 2, L equals 0, M equals 0, and MS equals plus 1/2. Go ahead and do silver now. And there's your answer. N equals 5, L equals 2, M equals plus 1, and MS equals plus 1/2. And then let's try for lithium. There's your answer. Lithium is N equals 3, L equals 1, M equals minus 1, and MS is plus 1/2. Then your last example is ceranium. And N equals 6, L equals 3, M equals plus 2, and MS equals a negative 1/2. And there you go.